force is equal to the change in momentum. Remember, delta, this symbol is a Greek symbol. Delta, it means change in. So change in momentum over change in time. So if you think of a car accident, let's say, the cars in the past used to be designed with very like steel bumpers that really wouldn't crush on impact, right? So the time this is force, and change in P, this is the change in momentum. Change in T is the time. The change in momentum, we're increasing the force. So if there's an increase in the mass in motion, there's going to be more force applied in an accident, let's say. If we increase the time, remember, if you increase the denominator of a number, the number itself becomes smaller, right? So if this number gets bigger, that force is going to be smaller. So if you increase this, you decrease the force. So think about it when automobile engineers have to think about the force-momentum relationship when they're designing automobiles to be safe. If they increase the time, so the time it takes for the car to stop in an accident, they decrease the force applied in the accident. So the driver and the passengers would experience less force. So it'd be safer, right? In the past, the old cars used to have like steel bumpers, and if there were an accident, they'd stop immediately. But there was no, they'd shorten this increasing the force. So they'd come to a stop very fast. Cars today really are made of a lot of the body of the car is plastic, so it crushes slowly in comparison to the steel bumpered cars. And that lengthens this time. So when it lengthens this time, that means the force that's going to be applied to the driver and the passengers is going to be decreased. So it's safer to drive. So car engineers, automobile engineers have to think about the force-momentum relationship when they're looking at designing safe cars to drive. Because in an accident, there are going to be forces, right? Because that's a collision. So to minimize the force, the impact experienced by driver and passenger, you can maximize this time. So increasing the time it takes for that car to stop, right? If it stops all of a sudden, that's a force. That's going to provide a very, very massive force on the driver and the passengers. However, if the crash occurs kind of in slow motion, it's going to be less of a force on the driver and the passenger, so it'd be safer.